Waves transfer energy from one place to another. You should already know how to describe them in terms of frequency, wavelength and amplitude, which we looked at in another video. In this video, we're going to look at two ways they can be classified. Waves are produced as a result of vibrations and can be classified as transverse or longitudinal. Whether they are transverse or longitudinal depends upon how the particles are made to vibrate as the energy passes. Let's look at longitudinal first. This is where the particles vibrate parallel to the direction in which the wave of energy is travelling. Notice that the ends of the slinky don't ever leave the hands holding them. It's only the energy that travels. The places where the coils or particles are bunched together are called compressions. Where they are furthest apart are called rarefactions. An example of longitudinal waves is sound. When a drum is struck, the drum skin vibrates, which causes the air particles next to it to vibrate. This causes the next air particle to vibrate, then the next, and so on until the vibration reaches the ear, causing the eardrum to vibrate. The vibrating air speeds away from the source, creating a sound wave. Let's look at another type of wave, transverse waves. The hand moves up and down, as does the slinky, but the wave itself moves from left to right, so the particles vibrate at 90 degrees to the direction that the energy is moving. We can simply think of it as, in longitudinal waves, the hand pulses horizontally, pushing and pulling, and the wave energy also moves horizontally, back and forward. Whereas in transverse waves, the hand moves up and down, but the wave energy still moves horizontally. Again, the ends of the slinky never leave the hands holding it, it's just the energy that moves along. Transverse waves are usually used to show the wavelength and amplitude. Pause the video and see if you can remember how to label the amplitude and wavelength on the diagram. Did you get them right? The waves on the surface of water are transverse waves. They make the water surface go up and down. All types of electromagnetic waves, like visible light, are also transverse waves. So, now you should be able to describe the differences between transverse waves and longitudinal waves. Remember, it is the energy and not the slinky itself that travels.